Great. Thank you, everyone, for joining. Thank you to Victoria and John for setting up a great present, great conference. And so my name is Mohit Sarveiya. I'm a GD in Kotlin and Android, and I'm going to share with you how to, best practices for testing Kotlin flows from my experience. So what I'm going to talk about in this presentation is first start with some foundations, things that you should know, some basics, and then we're going to build upon those basics. And I'm going to share with you some useful libraries that you could use that are out there for helping you to test flows. And I'll share with you then, how what a state flow is and what a shared flow is and how they work and their features. And that's what we're going to talk about. So let's start with foundations, things that you should know, things that will be helpful. So, foundations like the basics are how do you set up a test and what do you need to do. So let's start with a very simple example. I suppose you're building an app and you're consuming some external service. And the service could be anything like GraphQL, gRPC, or REST service API. And I'm sure like you have some component that provides you with a flow of data, flow stream of data. Now, like when you look at libraries like gRPC or GraphQL, they have a layer like a coroutines integration layer that provides you the ability to consume like a stream of data through flows that you could use. So suppose you had a very simple example of that and you were interacting with this flow, and when the stream came into your app, your architecture, you process the data, to display it in the UI. So you may have a flow like this, flow of data, and you had some business logic, in your filter, your flat map, and at the end, in this flow, you're generating some output. And I want to be able to test this very simple example. So how do I go about doing that? So how do you test this flow? So there are many different cases that we could test. We could test, the error case, a successful case. Let's look at the simplest case of a successful, that the data goes through, and successfully gives me an output. So the first step is that when you look at a flow, and the way you could read from it and get data from it is by collecting from it. There's a collect method, and the collect method is a suspending method. And in coroutines, in order to be able to call suspending methods, you need to create a coroutine, yourself. You can't call suspending methods from regular methods. So first things that I need to do is to create a coroutine, for my test. And one way to go about doing that is to create a coroutine using this method called run blocking test. This is provided to you by the coroutines library. They have a testing module in there. They provide you with this method that you could use. And this creates a coroutine. And what it does internally is that, when you create a coroutine, you need to specify the scope that it runs on. So it has a specialized test scope that it creates for you. And it also creates for you a dispatcher that your coroutine is going to run on. You get this special features with this dispatcher, the ability to control like virtual time, etc. So everything that you specify in this Lambda block, which is your test body, is going to run inside of this coroutine. And so everything that you specify in here. So how do I go about first testing this flow? So I'm going to create a mock flow. I'll show you how you would do that. And next thing that I'm going to do is that I'm going to collect from it. I'm going to start to read from it. So this flow is, assume this flow is, you want to get all the data from it. So toList is a terminal method. One of the terminal methods, like collect is a terminal method, single. And toList, what it does is that internally it reads from the flow, collects from it, and puts everything inside of a list. And it gives you back that list. Here's everything that I collected from the flow. So what I could do when I call toList, it will basically start the upstream flow, start this flow. It will go through my logic that I have in map, flat map, etc. And then I could do verification on it. So the way the toList works is that it takes each item and puts it inside of a list. And then what I could do is that should contain all is something useful from a library called Fluent that gives you really nice assertions like in these infix types of functions. And I'm basically doing an assertion on what I expect the output should be. So this is a very simple example of testing a flow, and I'm reading from the flow and I'm doing a assertion and verifications on it. So when you look at this example, the first thing basic to understand is how run blocking tests works internally. So in my experience, when you're writing code, you get many times you have to go inside to the source and understand how is the test coroutine being set up. So how does this work? So when it takes in your test body, and this method has three different steps, three different phases. So first thing that it does is that it does set up. It creates a test coroutine. And the next thing that it does is that it runs the test that you give it to your test body. Everything logic that you're testing, it gives it and runs it in an async. And when you look at this code, you'll see that it also advances time until it's idle. What that means is that I may have some code that I'm testing that has delays. And what it will do is that it will like advance virtual time forward for those delays. And the last thing that it does after running your tests is to attempt to clean up. When you're writing a test, you were probably launching some coroutines inside of that test body. And as you know, like a coroutine has a job, and which determines is your coroutine completed, is it active, and attempts to clean them up. One common error that happens a lot, that a lot of people, I think, from my experience, I found is that you'll get this problem of there's a coroutine that couldn't be cleaned up, and it's active, could be active. A number of reasons why that could happen. And so these are the three different steps that this method sets up your test. So this is a very simple example, the basics of how this works, how you set up your test. So when I in this example, when I created a coroutine for my test, I chose run blocking tests. So in the community, a lot of people, they have different approaches. So one approach is that for all of your unit tests, you could use that run blocking test method and set it up. Another, approach you could take is that I'm only going to use that method if I'm testing delays. And and there are different types of utilities you could use for that. And if I have very basic cases of testing like non-delays, I could use run blocking, which also creates a coroutine for you. And that was what people used before run blocking tests was introduced. So those are the two different approaches that I've seen from my experience that people take. So next thing, let's build upon this basic knowledge. What are the useful libraries that are out there that help you to test flows? And there's one library by Square that's useful that I use called Turbine. And I'll show you examples of how to use that. So what is a better way to collect flows? So one approach you could take is that you don't have to use that library, but if you don't use it, then you have to call these terminal methods like single or toList or collect. That approach also works. So this library by Square, and thank you to Square for creating this library. This is a pattern that was used in the SQLite testing, in the SQLite library. This was a pattern that was used that was extracted out And what this pattern does is that it provides a really nice API to do verifications on flows. And these are the things that it is able to help you with. I want to verify like the order of emissions. I want to verify my flow has emitted everything, got nothing more to emit, or maybe there's an error or a timeout. So what this library provides is an extension on a flow called a test, and inside of this, the argument of this method is a lambda. And uh, and what this library has is basically this is the API that it provides, the ability to verify, to expect an item. I expect some item from my flow. I expect that my flow shouldn't give me any output, give me any items emitted, or that it emitted some error, and or everything has been emitted by the flow and there's nothing more. So these are the three different methods that you could use to be able to in your test to do for your testing. So let's look at a simple example. Suppose I want to verify the order of items that are emitted. And so I could write my previous test like this: flow of data.test, and say expect item, grab me the first thing that was emitted. I could do a verification there. Then grab me the second item or the third item. If the order was changed, if the number three came before two, then your test is going to fail. So it's really nice, provides you with the ability to verify the order of emissions. And if you were to miss like verifying some emission, something was left over and you didn't account for it in your test, it tells you that, hey, you missed it. You missed a certain event of verifying it in your test. So which is really nice. So the other thing that's nice is completion, that my flow completed. So if I put in the last, every time you use this extension, it's required that you verify that there's no more emissions and you put a complete in there. And basically, if you don't put it in there, you'll say that, there's an unconsumed event that was emitted by your flow that you didn't do a verification on, which was the completion. So this is really helpful for writing really good tests. So how does Turbine work underneath hood? It provides this nice API for you. What it does is that it takes in whatever flow you're testing, and what it does is that it stores, basically it creates a wrapper of an event and stores it into a channel. So a channel is basically a blocking queue, or like a contract similar to a subject in RxJava. So it's a construct that allows you to send things to it and you can receive things from it. So what it does is that this channel is unlimited. So the channel internally has, a buffer, and it's unlimited. It grows as you add more things to it. And these are the events that it basically adds to this channel. So whenever something gets emitted, it wraps it into this item and puts it in there. And then it does that for every emission. And when it gets to the last portion of it, when everything has been read from the flow, it adds a completion event to this channel. So what you have is kind of like a history of everything that your flow emitted that you could query with like those methods, expect that effects. So if there's an error, it will also catch that because I'll show you, it wraps it in a try and clutch when it collects from your flow. So the completion is also added in there. So the way you could query this, as I showed earlier, is with these methods, But there's also a way to specify a timeout, like in your test, that after this period of time, it should time out. There shouldn't be any emissions. So what it does internally is creates a coroutine, takes basically a channel. So the launch method is creating a coroutine, which is the consumer, and it's reading from the flow by calling the collect method, and it's sending everything to this channel. And then you could query, you're able to utilize the methods in the flow turbine class to be able to query basically this channel. So it does, this is what it does, takes everything into this channel, and I could also verify if it's completed. So that's how this simple example works underneath the hood and using Turbine. So that's a very useful library that that you could use if you want. The other thing, so now let's talk about state flows and let's try to build upon. So in my example now, I'll use Turbine to explain the features of state flows. And well, state flows, are now very, very commonly used to be able to architect your features, right? Either whether you're using MVVM or MBI. So what is a state flow? A state flow is a construct that allows you to emit like events, the UI states, for example, to multiple consumers. Usually in Android, your consumer is the view. So there's a concept of a cold flow and a hot flow. A cold flow is a flow where when you collect from it, it consistently will start the upstream and give you consistently the same things over again. But a hot flow is something that's very, very different. It's independent of its collectors, and it exists independent of its collectors. And how do you set up? There are two types of ways to create a hot flow. You could use a mutable state flow class or a mutable shared flow class. How do you create a mutable state flow? Suppose like we're in Android land and we are creating some feature where you have a view model interacting with the view, and you may expose some stream of UI states that the view renders. So you could set up your UI state very commonly, where it's a very simple example is with a seal class, which has success and which has basically some uh, um, which has some failure case. So these are two cases. It could be more than these two cases in your seal class that you could have. So suppose I want to create a mutable state flow, and the way you go about that is that when you go and create a mutable state flow, it always has to have a default value. The default value could be null if you want. So in here, default value is as a success. Could be loading. Loading might make more sense depending on your use case. So I have this state flow in my view model. One common practice is that in your view model, you have an internal state flow that you push things to, but you expose a read-only flow externally. So there is a method called state flow that, as state flow, I think it's called. So here's a very simple example where I'm just testing that, that it emit. The first thing that is going to emit, to your view is the default value, which is of success. So that's what I'm basically testing here. I'm verifying that. So the other thing about state flow and shared flows to understand is that they don't, because it's a hot flow, unlike a cold flow, it doesn't complete normally. So when you read from it, or like a cold flow, eventually it will call the onComplete method, but that's not the case with the state flow. So if I were to have this test here in which I do expect complete, you'll see that this test basically will fail because the test coroutine will stay there, will stay there. It will basically time out looking for the onComplete event, never really registered. So the test coroutine will, keep on waiting when it's reading from the state flow. And because you can see here that, when you call collect is a suspending method, and will stay suspended. It won't complete. It won't really go to the point where it needs to, where, you're sending to this channel an event of completion. So, but it does complete exceptionally. So you could have a subscriber listening to the state flow, and I want to turn off that subscriber at some point. I could cancel the coroutine that it's running on. And that's one common thing that I think I help people with. So you have a state flow here where this is a very simple example. It's not a unit test where the onComplete, I have an onComplete method here. So this won't get called, ever, because the state flow won't complete like a cold flow. and it's not a cold flow because it's a hot flow, so it won't log. But if I were to write this in, if I were to pull this into my test with turbine, you'll see is that this on complete method will get called because turbine underneath the hood will cancel the job that is collecting this flow from. So when you look at internally, what's happening is that you have at certain point when it goes to clean up, it will basically take the job of that coroutine and then call cancel on it. And when it does so, you'll see that that on complete at the end of your test, it will get called because the subscriber completed, exceptionally due to an exception, cancellation exception, and that's something important to understand. So you'll see that this will log in this very very simple test. So the other thing about a state flow is that it has two features that are, that it has the ability to conflate, and you when you subscribe to it, you always get the most recent emission. So for example, if I were to have this test here where I have a default value of success and I emit an error, the most recent thing that I sent to this state flow was an error. And you'll see that this test is going to fail because when you call expect item, what you got from the flow, that was the most recent, which is an error. So most recent submission was an error. So this is the passing test. This very common problem that I found occurs a lot is that so this is the feature that a state flow has, is the ability to distinct. And then when you send something to it, when you do state flow dot emit or dot value, it stores the most recent emission externally. And so that's how state flows work. So when you're building this feature, you also, you have your view model that's interacting with some repository, and that's also it may be a stream of data that you're consuming, basically and based on whatever gets emitted, you generate a UI state in your view model and give it to the view. So how do you go about mocking basically your the flow from your repository? So one way you could do it is to use Mockito. You could also create fakes. So how do you go about creating a fake? So there are two approaches you could take that people take in the community, I found. One is to use channels, one is to use either a state or shared flow. So suppose that you have your repository, which is an interface, and it has a flow of results. And you could create a fake with this using a channel. I have a channel here. You could use any type of channel that you want. This example is a rendezvous channel. And and I have a method that I basically, in my test, I could call this method, give me, the flow from this channel, which is what consume as flow does. And the other thing that you could do is that I could have a method in there to emit some particular result. So for my test, I could do like either a failure or a success. And then, so I have an emit for failure and emit a successful result. The downside of using a channel is that you have to close it. It's very important, very, very important in your teardown of your test to be able to clean up and close your channel. Otherwise, you'll get an OOM. If you run on Jenkins, you may encounter that if you have a lot more tests. So the other approach you can take, and I'll share with you the approach of using a state flow and the downsides of it. So with the state flow, basically, you could very similar have expose a read-only flow. You could have a method where you push something to it like a result. So the downside of that approach is that you may not want to conflate behavior at the repo level. Like I want to be able to handle the effects of each emission that happens from the repository layer. So that's why I don't use a state flow. I personally go with the approach of using a channel, basically. So I'll show you when we talk about shared flows how to implement that and to implement that fake repository using a shared flow. So when you're building, your feature, it's based on your complexity. What happens is that the way, you may be, interacting with flows that are part of some different feature, you may have shared state. And how do you, and it then becomes really complex. So if you have a really complex feature, something I see commonly is that the most common thing that you will do at that layer, the view model layer, the most common, which is combining multiple flows together. You combine their emissions together and you push to the state flow some type of a UI state. And these flows might be due to different reason, like maybe some UI interaction or something that you're sharing between multiple features. So there is a website called Flow Marbles that I really, really recommend, which allows you to understand how flow combine, merge, and all that works. So the way combine works is that it takes in multiple emissions like this, one in A, give you one A. You could specify how you want to combine them. You could run to a case where one of them only emitted something, not the other, and you could combine that together. And then similar with this example, a B took the previous value of 2 from the other flow. Understanding that I found is really important, like flow combine from, my experience, it's very commonly used when you have a really complex feature. And one approach you could take is that obviously you don't want a lot of logic, a lot of logic in your view model. And you could extract away all of this logic, combining flows together into some different class, call it a stakeholder or whatever you want to call it. And so, for example, you may have two flows, you combine them together and you produce some form of state from that. And you may want to push that out. Then you push that out to your state flow here to the view, here, render it. So when you could have multiple flows combined, like 3 or 4, and you could test this by creating, mock flows with some particular things that you wanted to emit and inject that into this component, state holder, or some class. And then you could read from the state flow, and then it will basically and verify, different cases that you would expect based on what the flow, the individual flows should be emitting. So what I found is there are some challenges that commonly happen. So is that, when you're building really complex you might see bugs where, like, common question that comes up is that something didn't get emitted from the state flow, and most commonly didn't get emitted because it got conflated. You only got the most recent value. So the other thing is that as you're building a complex feature and you're combining multiple flows together, if someone externally tries, it becomes really difficult to comprehend the data flows. And there are different ways you could go about, like, building abstractions to be able to easily handle this, or architecturally. So these are common challenges that come up as you're building features. So the last thing that I want to talk about are shared flows, and which is different than state flows. They have a lot more features, and I personally like using shared flows. So with the shared flow, like, it's similar to a state flow. You could broadcast events out, but it has this extra feature where you could replay, some number of events that I want. Like, a new subscriber comes in, replace X number of events to them. It also has the ability to handle, like, it has a buffer, and you could have a consumer that's emitting something really, really fast, and it could store those emissions, like, inside of this buffer, and your consumers might be slow, and you could basically read from this. And there are different ways you could handle that case. So that's what's really nice. These two extra features are really nice about shared flows. So how do you set it up? Setting it up is very different. You don't have to specify a default value for the shared flow. So here is shared flow of just a string, and then you could emit something to it. So in this test, I'm emitting this string, and I have this, and then I start to read from it. So this test is going to fail. Why does it fail? So it fails because when it gets to the first, when you emitted something from your subscriber count was 0. So you could do stateflow dot subscriber count to know how many subscribers there are. And right now you have 0 subscribers. And here I didn't specify, this is the simplest use case. I didn't specify any replay number at all. So it won't replay anything to any new subscribers. So after I emitted something, then I had a subscriber come on and read from this flow. And then you didn't get anything. You didn't get an event 1 because by the time that you subscribed to it, there was no emission. So um, what does a passing test look like? So suppose the producer, which is this coroutine, I started lazily. So if I started lazily like this, so I have a consumer that's already there, subscriber count is 1 when I emit something from it, and then this test will pass. So I'm sharing these tests to help you to understand the behavior of these constructs. I think that's very useful. So there's a replay that you could set up. You could be any number 110 depending on your use case, like this, in the constructor, and you could then, if I were to set up a replay of 1, then this test that we saw previously will pass. So that's the replay feature that's useful. So as I shared before, one of the things that you could use shared flows for was to be able to create fake repositories like in your tests. The other approach, other than using channels, is you could create a fake repository like this, create a shared flow, which has a replay count of 1. And buffer overflow means is that if you were to, when it fills up the capacity, buffer capacity here, I want you to drop the oldest thing that was emitted. And there are different ones. There's buffer overflow suspend, which will suspend the coroutine. You could drop the most recent also. This is also used, you could also use this at the view model layer to create some form of abstraction where you could create like an abstraction API around this primitive where you could dispatch states, like an MVI type of abstraction that you could create. I saw that commonly used. So I could emit something to it, and if I want, you don't have to close it. In my opinion, you'll just make sure to null out this flow so that you don't run into any OOMs. So that's how you could use it for, in that layer of creating a fake for your repository. So the last thing I want to share, which is you may run into a case where you're testing some code, like you have an upstream flow and you want to convert it. There are extensions that allow you to convert it to either a state flow or shared flow. And you, depending on your use case, and and you could modify the behavior of that upstream flow when it starts, when it completes, etc. And these are 3 ways to do it. So if imagine I'm testing something, there's an upstream flow, and I could convert it to a shared flow with this. What this does internally is that it creates a coroutine, starts to collect from your upstream flow and pushes everything to the shared flow that it returns to you. It's the same thing with state in, which returns you immutable state flow. And it takes in what scope am I going to create a coroutine on? That's what it takes, the first argument. Second, what is the behavior of that upstream flow? And last, can tell me the replay count. So those are things that I could configure. So in this example, I am going to show you how while subscribe works. I created a scope, a separate scope, by the way, separate scope from the run blocking test scope. And I put it into the share in. So in that scope, it will start to read from that upstream flow, and it will basically begin to read from it. So one thing about while subscribed is that when you create this shared flow, it won't start the upstream because that's one of the behavior. It waits until there's at least 1 subscriber. So on start won't log here. And it will. So these are two behaviors it has. It waits until there's at least one subscriber to that shared flow to start basically that upstream. It also remains active until the sharing scope is not canceled. When you cancel it, this all the subscribers will complete. So basically, the way and here in this example, I have a consumer, I have a subscriber reading from my shared flow. And then as soon as I start reading from it, got one subscriber, the at upstream flow, you'll see it log out on start. So that's the behavior of while subscribe. The other behavior that's really allows you to control the upstream flow, you can make it eager. I want you to start. Doesn't matter how many subscribers there are. When you create the shared flow, I want you to start the upstream flow. So if I in here started and make this eager, you'll see that right off of the bat, you'll see this logged out even before I tried to read from this shared flow. And that's what this behavior it has. And there's all that's what the behavior eagerly is. There's also lastly lazily, which is very similar to wow subscribe, but it also stops the upstream flow even if you cancel the external scope. So if I were to set this up like this, very similar to, you'll see that this gets logged out even though I don't have consumers. You'll see that the incomplete will never log out either. It will log out if there is an exception, if you cancel, the coroutine you're collecting in your subscriber. So that's the behavior of lazily. So those are the three different things that you could use that are commonly used in advanced cases. I hope that was helpful. Everything that I spoke about, I wrote a blog post on my website, codingwithmohit.com. I wrote a lot of articles based on my experience of helping many people, and I hope that was helpful for you. And I'll say thank you to John and Victoria and all the other speakers. Really informative presentation discussions, and thank you for having me. If you have any questions, let me know.
Awesome. Thank you very much. If there are any questions, feel free, ask them in the unit testing Kotlin flows. Don't be shy.